Okay. We appear to be on air. Okay, I think we can start. I think I've vamped long enough. Guys, I don't usually do this. Okay.
Act like you've been here before, Blair. Act like
cut point.
Shh. 3, 2, 1. No, just go.
Well, I would go if you would stop talking. Okay.
Well, I thought you were breathing. You keep breathing, but then you don't say anything.
Stop. Okay. This is TWIS. This Week in Science, episode number 652, recorded on Wednesday, January 3rd, 2018. When the doctor's away, the co-host will play. Hi, everyone. I'm Blair Bazdarich, and today on This Week in Science, we'll fill your head with sexy moths, ancient Americans, and the cure to global warming. But first...
Disclaimer. It's a new year, calendarically speaking anyhow. In reality, it's just the same number of days stretched out before us that have always been there. That place we're going, that thing racing towards us, that once it meets us head on, makes a whooshing sound as it goes past. Every day, a new challenge presents itself. Every day, a new opportunity to learn. Every day, a new chance to expand our horizons by adding new knowledge to our understanding of the world. And while we've seen many strange things on this journey of ours already, every week we will be right here with you. And together, we'll see many more here on This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Blair.
Good science to you, Justin. Welcome, everyone else out there. I am very sorry to say we are without Dr. Kiki tonight, but the two of us are going to do our best to bring the science anyhow. Today was supposed to be our prediction show, but instead we will be doing that next week on the 10th, January 10th. I can do math. And tonight, we still have lots of great science news for you. Since we didn't do any science news last week, we certainly have quite a bit to get through. On this week's show, we have so much. I brought moth sex. I brought political instability. Oh, no, wait, that was already here. I brought an update on bats and some sneaky bacteria. What did you bring, Justin?
I've got some ancient Americans, the end of cure to global warming, and prediction. Oh, wait, we're doing that next week. And then I'll probably find and read something.
You're going to find something mid-show? Ooh.
I'm going to find something during the show.
Is that a first? I don't know. We'll see.
No, it is not a first.
No, it's not a first?
No.
Very good. Do you have one more thing you want to tell us before the show starts?
I probably do. Let me check the show notes.
Well, while Justin's looking, let me tell you that we still have calendars available.
There are calendars.
So there are still some calendars. I know it's already January, but you're only a couple days in. Shipping is only a couple days for you're inside the United States. So go ahead and order those calendars before January's up. You still have a squirrel to color. So go ahead and order those. And if you're in the San Francisco Bay Area, bring your calendar to SF Sketchfest at the California Academy of Sciences on January 18th. On Thursday, January 18th, we will be doing a live TWIS show at the California Academy of Sciences as part of Sketchfest Nightlife. You can get tickets at Cal Academy's website or at sfsketchfest.com. And you can come even if you don't have a calendar. That's okay. But if you have one, I'll definitely sign it.
That is going to be a blast. And as you are listening now to the show, I want to remind you that there are other ways you could be listening. You could be subscribing to TWIS as a podcast on iTunes and the Google Play podcast portal, Stitcher, Spreaker, TuneIn. You can also find us on the YouTube, Facebook even, by searching for This Week in Science, or just visit twis.org. But now it's time for
Science news. Do you have science news for us today?
I do. So, new Native American heritage history discovery was made in Alaska. A previously unknown population being called ancient Beringians. Some sort of play off the Bering Strait, I suppose. Up till now, it had been believed that the earliest settlers of the Americas crossed from what is now Russia into Alaska via an ancient land bridge spanning the Bering Strait. It was during an ice age, so this would have been walkable. And now it appears there's even more evidence to continue believing that. One of the outstanding questions, though, still has been, were there waves of migration? Are we talking about one peoples when we talk about the Native Americans and their origin? Or are we talking about waves of migration or a back and forth migration? And over how much time did that take place? In the new study, an international team of researchers led by the universities of Cambridge and Copenhagen sequenced the full genome of an infant, a girl named Sachiti Anatide Gay, or Sunrise Child Girl, by the local Native community, whose remains were found at the Upward Sun River archaeological site back in 2013. To their surprise, they found that although this child lived about 11,500 years ago, long after people first arrived in the region, several thousand years actually after settlements were already in place as far south as Chile, her genetic information did not match either the two recognized branches of early Native Americans, which are the northern branch and the southern branch. Instead, she appeared to have belonged to, no, not aliens, but an entirely distinct Native American population they're calling the ancient Beringians. Further analysis then revealed that the ancient Beringians were an offshoot of the same ancestor population as the northern and southern Native American groups, but that they were separated from that population early in their history. Timeline here allowed researchers to construct a picture of how and when the continent might have been settled by a common founding population of ancestral Native Americans who would have been also ancestral to the ancient Beringians. So the study was led by Professor Eske Willerslev, who holds a position at both St. John's College, University of Cambridge, UK, and the University of Copenhagen in Denmark. The ancient Beringians diversified from other Native Americans before any ancient or living Native American population sequenced to date. This is Quotey voice. It's basically a relic population of an ancestral group which was common to all Native Americans. So the sequenced genetic data gave us enormous potential in terms of answering questions relating to the early peopling of Americas. We were able to show that people probably entered Alaska before 20,000 years ago. It's the first time that we've had direct genomic evidence that all Native Americans can be traced back to one source population via a single founding migration event. Study compared data from the Upward Sun River remains with both ancient genomes and those of numerous present-day populations. That allowed the researchers to establish that the ancient group was more closely related to early Native Americans than their Asian and Eurasian ancestors, and then to determine the precise nature of that relationship, and how over time they split into the distinct populations. The Upward Sun River genome shows that the ancient Barraginians were isolated from the common ancestral native population both before the northern and southern divide and after the ancestral source population was itself isolated from other groups in Asia. Researchers say this means that they were already in the Americas when these subdivisionings started to take place. So, according to the researchers' timeline, ancestral population first emerged as a separate group around 36,000 years ago, probably somewhere in Northeast Asia. Constant contact with Asian populations continued, they figure, until about 25,000 years ago, when the gene flow between the two groups ceased. This ceasing of genetic flow likely indicates the time when they were either isolated by weather or left the continent. Right? So it kind of puts it at about 25,000 years ago as the plausible migration time.
Wow. I really like that in the article, one of the researchers says, it would be difficult to overstate the importance of this newly revealed people to our understanding of how ancient populations came to inhabit the Americas. I get that. I definitely agree. I think that I talk all the time about how our science books in relation to space will be so different. Just basic, elementary, middle, high school textbooks will be so different. They probably are now than when we were kids, and they will be again. This is a situation where something the closest to home you can possibly get in terms of those of us that are in the United States, right, is rewritten. And will continue to be rewritten as we find these things. But I also just like when a scientist is really excited about their own finding. I feel like a lot of scientists would say that it would be difficult to overstate the importance of their new finding.
So these ancient Barraginians themselves sort of disappeared, although it looks like they were absorbed. The northern group that had headed south went back north, kind of had a revisiting of those territories after the glaciers had melted. So they believe they sort of merged back in, so that the current Alaskan and far northern Native Americans are still of that same group, but they're they're more closely related to the northern branches. It's also interesting here is This is we talk about the text. You were talking about textbooks being rewritten. As recent as the early 2000s, as these Clovis points in the lower United States and areas were starting to get dated to like 13,000 years, 13,500 years old. There was enormous controversy about them, and it was because and I'm always remembering, I might be slightly misremembering, my textbooks, I believe, said that crossing took place 9,000 years ago. There's a site in Pennsylvania that they claim might be 19,000 years old or somewhere in that range, but way out of the extreme. But my favorite is Jacques Cinq-Mars, French-Canadian archaeologist. He dated bones that had human butchering marks on them to being 24,000 years old. And this is up in the Yukon. He did this back in the late 70s, early 80s. He published many papers between 1979 and 2001 on the Bluefish Caves, where he'd found this. Jacques Cinq-Mars was literally laughed at when he was presenting at archaeological conferences and that sort of thing. Nobody took this guy seriously. He became, I think, a little bit jaded by the experience, in fact. But always stuck to it. Like, nope, these are humans in the Yukon, in these caves, 24,000 years ago. Deal with it. Here's the evidence. I found it. But wasn't taken seriously because his results didn't fit the timeline. Didn't fit the textbook. even though he had the evidence, right?
Right.
And now here's a population. Here's evidence that shows his timeline is right there in it. It's the right area, it's the right region, and it's the right time frame. Everything now fits. That this discovery of his absolutely is credible for the earliest evidence of peoples in the Americas. So yeah, textbooks do get rewritten. Sometimes long after they should have been. Often, I'd actually say often long after they should have been. In some of these cases, it seems like there's evidence that's out there. And you know what kind of helped, like the ended the debate over the Clovis Point sites. There was scientific evidence showing the dating, but there continued to be controversy about it. And then they started finding older sites in South America. And after a while, it's kind of hard to argue that one site is too old when there's even older sites being discovered further away from where you thought they should be.
Well, you know what they say, Justin. Time makes fools of us all.
Yes. I guess. I don't know. I feel like it sort of does it. You know, whenever you look back, you have to say, look, you look at the data points you have and you make your judgments on those. But when these outliers show up, they need to be taken seriously. They need to be studied seriously, so that we can come to these conclusions a little quicker. Guys, Sink Mars even admitted that he didn't go back and do as much further research on the caves in the surrounding area because he was so discouraged. And he admitted at some point the sort of regretting being that discouraged, even though he stuck to his guns all the way through. This is my finding. I stand by it. There may be other. It's sort of like when we're talking about the origins of human history and it all being in East Africa, right? Well, that's where we found some early finds. That's where all the looking is. There could have been, over this last several decades, a lot more looking in those Alaskan areas to make more finds like the one that we just now have, if we had taken seriously the evidence that was presented before us.
Well, I mean, when it comes to human evolution, when it comes to exploring the laws of our universe and dark matter and things like that, when it comes to outer space, when it comes to deep sea, all these things that we're exploring and trying to figure out, we're looking through kind of a telescope, right? So we're only seeing a certain radius of information. We're getting information. It doesn't make those pieces of information any less valid, but as we can get closer, our field of vision gets wider. And eventually, as the field of vision gets wider and wider and wider, we can see the whole picture. It's kind of, it's actually almost like a zoom out, right? But it's just, or it's like getting blinders removed. It's just, you're getting these outliers. And when they show up as outliers, they don't make any sense. But as you start to see the whole picture, it becomes a beautiful tapestry of data points that tells a new story. So, excellent. Okay, are you ready to jump into an extended animal corner?
Always.
Okay, good.
I am always ready to jump into an extended animal corner.
Creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels.
What you got, Blair?
I have so much for you today. So first, I have a headline that is somewhat misleading, but I do really appreciate the headline. The headline says, political instability and weak governance leads to loss of species. You may think this article is about the good old United States of America, but alas, it is not. It is actually about the globe. This is about all governances around the world. This is a study from University of Cambridge. And again, thinking about kind of part of the picture versus the whole picture, when we think about saving species, a lot of the time we look at one or two factors. We look at pollution and water quality. We look at habitat loss. We look at hunting. We look at protections. We look at invasive species. We look at being taken out of the wild for the pet trade. We look at noise pollution or light pollution, right? We look at single items. But the University of Cambridge wanted to look at an overarching theme in an area that could very clearly point towards a period of trouble for biodiversity hotspots and species on the decline. And so this new study found that low levels of effective national governance are actually the strongest predictor of declining species, more than economic growth, more than climate change, more than surges in human population. This was published in Nature a couple weeks ago, and they showed that protected conservation areas do maintain wild diversity. So protected space is really important, but that only works when they're in countries that are stable politically and they have sturdy legal and social structures, which makes sense if you think about it. Because if I tell you, you can't go in there and you can't mess with those birds, but there's nobody around to stop you, I don't know how effective of a protection that might be. So they looked at, so my main issue with this study is that it's pretty short term overall. It's actually starting in 1990. If this study was starting in even the early 1900s, I might think that it had a little bit more of a longitudinal strength to it, but this is a good start. It's definitely a good start. I haven't read any articles or studies that actually focused on this before, so I'll take it. But it started since 1990, and it was looking at water birds. And that's because water birds live in wetlands. Wetlands are very diverse, but they are also extremely susceptible to changes because of all of those things that I mentioned at the beginning. Those all affect wetlands. And first and foremost, water quality is a huge problem with wetlands, not to mention a lot of people go in and around and near wetlands. So they looked at these wetland bird species, and they analyzed 2.4 million count records of 461 water bird species across 26,000 different survey sites. So the time span is not long, but the breadth in that time span of data is pretty vast. They compared this water bird species distribution to the Worldwide Governance Indicators, WGI, which measure violence rates, rule of law to political corruption, gross domestic product, conservation performance, all these different indicators. And they found that waterborne decline was greater in regions of the world where governance is less effective. And they found that to be Western and Central Asia, South America, and Sub-Saharan Africa had the least effective governance according to the Worldwide Governance Indicators. And they found that was where the waterbird decline was the greatest. They say that ineffective governance could undermine benefits of biodiversity conservation efforts that are pretty popular in those areas. If you think about it, Southeast Asia, Western Asia, Central Asia, South America, Africa, those are all areas where there are a lot of, let's say, high-profile conservation species. Mm-hmm. And so there's definitely a lot of money, a lot of man and woman power, a lot of effort going into protecting those areas and protecting animals in those areas. But it sounds like they're kind of going to waste in a lot of those areas because the governance is somewhat unstable. They say that compared to all the anthropogenic impacts tested by researchers, that would be all the stuff I listed at the beginning, pollution, hunting, stuff like that, national governance was the most significant. It was more significant than any of the other anthropogenic impacts. And ineffective governance is often also associated with a lack of environmental enforcement and investment, which also leads to habitat loss. And in terms of when you pull out individual indicators, habitat loss is the greatest impact on endangered or extinct species. So habitat loss, obviously, if a animal doesn't have a place to live, nothing else really matters. So when you see habitat loss increasing where there's ineffective governance, then you kind of see this feedback loop and this snowballing effect. They also looked at a relationship between the speed of GDP growth and biodiversity, and they found that the faster the GDP per capita was growing, the greater the decline in waterbird species. So when there's quick economic growth, that can also cause a lot of problems. So this story, I kind of opened it because I thought it was a snarky retort on a lot of the governmental decisions relating to habitats and species going on this side of the world where we are right now. And it turned out that it was actually a very interesting look at how, if we're going to try to save species, or as I prefer to think about it, saving habitats, right? I've talked about this a lot on the show, that saving a species doesn't matter if it doesn't have a place to live. So really we should be looking at saving habitats, but that doesn't really do much if the government with people living around that habitat is not stable enough to let it be.
But here's the really sad thing, that this is what I'm hearing, and maybe I'm mishearing this, because there's not a stable governance, and there's lack of funds and lack of governmental activities involved in this, in conservation. The conservation efforts are falling flat. But if you had a highly effective governance that had the wealth to do things, you'd probably see rapid growth of the economy and then the development of the area. So the alternative is,
good point.
Instead of exploiting it, you're just paving it and you're calling it develop instead of.
There's a difference between increasing the strength of a governance and throwing money at a governance. So those are two very different things. So basically how I see this is, if you want to save species and habitats, you have to help people first. And the way you help people is by making sure that they are well represented in their government, that they're getting what they need from their government. That isn't necessarily making sure that their GDP is increasing very quickly.
But my point would be not that you would be making sure that the GDP did anything, but that a well-organized government will likely increase its own GDP. Will be more stable for its people. It's more.
But remember, so GDP,
more willing to invest. You get
GDP can be high, and there still can be very poor people.
Oh yeah,
in an area. So that's the point, is that GDP is not a measure of representative government, of government that's stable, government that's representative or strong or well trusted. Those aren't really the same. So I think that you can still strengthen a government or a governance, and you don't necessarily create a quick spike in their GDP. That's not necessarily how that's going to work.
Right.
But also that would be a different kind of spike than what they've historically been measuring, so that might not have the same impact as well as it has in the past. But what I see this as is, if you want to save species, if you want to save environments, you have to save the people there as well. Which I think is a really important story. It's
my counterpoint is, it's going to be people are the problem.
But that also means
need is to
Justin,
get rid of all
they can be the solution. And that's my point, is that it's just it's a systems thinking problem. If instead of thinking about the species, you're thinking about the habitat. Instead of thinking about the habitat, you're thinking about the geographical region. And there might be a wild habitat and there might be a town next to it. But unless you consider both, you can't save an animal that's living in that wild habitat. That's how I see this story. You have to think about the system, and the humans are part of the system, ultimately. Anyway, so that was my controversial yelly story. Okay, so next I wanted to talk about something a little more fun. I wanted to talk about some invertebrate sex. So I brought a story about female moths and something that they do that actually is usually in the animal kingdom reserved for males. They use pheromones to attract males to them. And they do it with varying success. And that comes down to genes usually. So they are either deemed unattractive or attractive based on the pheromones that they release. And in a new piece of research from North Carolina State University, they found that unattractive moths have found a way to get around this issue where they are not wanted. They found that moths with unattractive pheromones actually would hang out really close to attractive females, and that this would help them reproduce when otherwise they might not find a mate. They also found, this is what was really interesting, that moths that were attractive or had, I guess, delicious pheromones also benefited when they were close to the unattractive females. So males that were more discerning could see them as even more beautiful next to the unattractive female. So, as I mentioned, this is something we haven't really seen with
And these are moths?
females very often. Yeah, these are moths. It's usually a male thing. The males puff up their chests. They do displays. They release pheromones. They do all this kind of stuff. They do a dance, you know. And so they will sometimes benefit from proximity to other individuals. This is something we haven't really seen with females before, especially with a pheromone signal. So it's not even that they're kind of just blending in amongst the pretty females. It's they're emitting a smell, and it's not a good one. But the males just kind of, I don't know, miss. they get confused and they get too close. Who knows? But they are having more success. They actually have little to no chance of mating when they are on their own, but these unattractive females can attract a male about 17% of the time when they're near an attractive female, which doesn't sound like a lot, but it's a whole heck of a lot more than 0. So they think that the males are making mistakes when they get closer. But
yeah, it would come down. Couldn't part of it be the range of this pheromone detection?
Yeah.
It just brings more males generally to the area, and then eventually one's like, all right, why not?
Oh, a female, okay. And then the other side of this coin, though, is the attractive females benefiting from being close to unattractive females as well. This is really a win-win for them. They mated sooner than attractive females that were alone or with other attractive females. So, I guess the males, the more discerning males, kind of see what else is happening nearby.
Oh,
and they go,
you seem like a reasonable mate. I want to look around a little bit. Hey, okay, you know what? Oh, hey, where you going?
Yep. So this is a mutually beneficial way that an otherwise undesirable trait would continue in the genetic line. So you could see how if unattractive pheromones have little to no chance of mating, those moths would essentially go away. There wouldn't be a lot of them, but this allows them to continue. It really reminded me of salmon and how they're sneaker males. This is with other species too, but I always think about the salmon that these sneaker males are small and undesirable to the females, but then when the big male's not looking and the females aren't looking, they run over and they fertilize all the eggs. So they benefit and they still continue on as these less desirable phenotype. So they found a way, life finds a way. They found a way to survive.
Yeah, and it also, it could be a strategy. I mean, there may be some benefit in being a tighter knit community. And one of the ways that nature found this, or it produced itself, is that those who were more social, because I think of it from the unattractive pheromone moth perspective, right? Or the case of the unattractive moth. If that moth is antisocial, it goes off on its own, it's not going to mate. But if it's social, if it likes being around other moths, if it wants to mate, wants in a moth, who knows? The more social moths will be more likely to reproduce, regardless of their.
That's very interesting. I like that. That's a very neat way to look at it.
Nature's way of weeding out the antisocial.
Yeah, that's great. Only extroverted moths may continue.
Yes.
All right. Well, I'm going to save my last bit of the corner for after the break because I think it is time for a break. We will be back in a little bit. Stay tuned for more This Week in Science. All right. I wanted to remind everyone that we do have calendars available. I did some coloring pages that you can color in every month. Heck, buy 2 or 3. Then you can color your own versions every month. Have your friend color one, your aunt color one. I don't know. But there's a few calendars left. Catch them while they're still available. They're available on our website, www.twis.org. Just click on the calendar in the upper right-hand corner, and you will have a calendar in no time. Also, please remember to visit us at SF Sketchfest on Thursday, January 18th, if you are in the San Francisco Bay Area. For the price of a nightlife ticket, very reasonable, you can listen to all sorts of fun science and comedy events happening throughout the California Academy of Sciences, and of course, your absolute favorite, us. There will be a live taping of This Week in Science at the Cal Academy on Thursday, January 18th. So go to calacademy.org or sfsketchfest.com for those tickets. Also, TWIS has merchandise you might enjoy. You can go to www.twis.org and you can find some swag. On that website, you can find our Zazzle store. Up on the top of the site, there's a little tab for the Zazzle store. You can go to twis.org, click on that, and you can buy all sorts of fun stuff. We have trucker hats, we have mouse pads, we have ties, we have wrapping paper, we have mugs, we have t-shirts, we have jumpers, we have all sorts of fun stuff. And if there's something that you really want from one of the previous calendars on a specific item, you can email me, blairbaz@twis.org. You can tweet at me, @Blair's Menagerie, and I promise I will do my best to get it up in the Zazzle store. So take a look around, let me know if there's anything that you want, and go ahead and buy all the stuff you wanted for Christmas that you didn't get. And if buying stuff just isn't your bag, that's totally fine. TWIS is supported by listeners like you, and you can help donate to pay for hosting, bandwidth, contractors we need to hire, fun things we try to do for the show. Any amount helps. $2, $5, $10, $100. It's you guys. It's the support. It's you all who support us who help make this show possible. We can accept donations a couple of ways. First, we have PayPal buttons on each show page on our website. So if you go to twis.org, click on broadcasts, look at a show, scroll down, you'll see PayPal donation buttons for all the different denominations, or you can pick your own. Or we have a Patreon account. If you go to patreon.com/thisweekinscience, it's kind of like a Kickstarter, but for media producers. So you can pay per month to help support the show. And there's all sorts of different kickbacks that you get for the different denominations. You can get an original piece of art by me. You can get a shout out at the end of the show. You can get an exclusive web hangout with us if you pay enough, you can even get a dinner at one of our houses.
Or you can just have the self-satisfaction of having donated $1 to a cool thing.
That's also true. Whatever you can do, we appreciate it. It's all helpful. And you know what? If you can't afford a donation, that's totally fine. You being here is enough. We can always use your help to get more people listening, though, because we want to spread this show far and wide. We want everyone listening to TWIS. So use your social networks for science, be they online or in person. Tell people to tune into TWIS. You can tell someone in person, let me help you. Subscribe to TWIS. Take their phone with their permission, of course, and help them sign up for TWIS.
Yeah, make sure if you're going to take it without their permission, make sure it's unlocked first.
Right, make sure it's unlocked.
Grab it when they're active texting, and then subscribe.
And if you listen on iTunes, you can also help by posting a review of TWIS. And you can help by giving thumbs up to recent reviews that were helpful to you. We want people to see the best reviews according to you, the most accurate reviews on iTunes, and we want some current ones up there since our show is always changing. I mean, we're at episode 650 something. No matter what you do to help us, thank you so much. We would not and could not do this show without you. Thanks.
Although technically, I feel like we can still do the show. It's just me talking to myself. I don't know if that's...
Stop talking over my excellent audio.
And we are back with more This Week in Science.
That's right. Before we listen to some more science news, we have our favorite segment in the show, our favorite new segment in the show, I should say. And that's This Week in What Has Science Done For Me Lately? So this week comes from Milady Carol. What has science done for me lately? Science underlies everything. Beyond the amazing new discoveries, they're the basics of life. I'm grateful that science has brought such amazing life to this beautiful rock. I'm grateful for my existence. I'm grateful for the hemispheres of my brain that bring me creativity and logic. I'm grateful for my family of humans and dogs. I'm grateful for the food that nature provides right in my backyard, and I'm grateful for its delicious nutrition. I'm grateful for the amazing herbs and spices and teas and coffee beans that make each morning smell and taste amazing, and for the energy that provides for my body. What has science done for me lately? Well, art is how I recognize it. Science is the very reason for me and all I hold dear. Thank you for all you do. I've been listening since 2006. Thanks, Milady Carol. It's a great one.
Wow.
Quite
2006.
poetic.
That's the very beginning.
Yeah, that's
At least of
but
the
a twinkle in Kiki's eye at that point. So remember, everyone, we need more stories. We want one of these every single week. So we would love you to write in to let us know what science has done for you lately. What does it do for you every day? Leave us a message on our Facebook page. Go to facebook.com/thisweekinscience, or you can email Dr. Kiki at kikifinch@gmail.com. We want to fill this every week with inspiring or funny or silly or just factual stories about what science has done for you lately. I'd still like a sonnet, guys. Get on the sonnet. Okay. All right. So, Justin, without further ado, do you have more science news?
Yes, a new feat of engineering may be the technology the world was looking for to end global warming.
The devil, you say?
Yeah. That new technology lies in fossil fuels.
No.
Engineers at the University are developing technologies that have the potential to economically convert and biomass into useful products, including electricity. Wait for it. Without emitting carbon dioxide into the atmosphere.
How?
Blair said skeptically. So in the first of two papers published in the journal Energy Environmental Science, Engineers report that they've devised a process that transforms shale gas into products such as methanol and gasoline, all while consuming carbon dioxide. The process can also be applied to coal and biomass to produce other useful products and things. Under certain conditions, the technology consumes all of the carbon dioxide it produces, plus additional carbon dioxide from an outside source. That's the first paper. The second paper report they found a way to greatly extend the lifetime of the particles that enable the chemical reaction to transform coal or other fuels into electricity and useful products over a length of time that has now commercial operation implications. Finally, same team discovered and patented a way with the potential to lower the capital costs in producing a fuel gas called syngas or syngas by about 50% over the traditional technology. The technology known as chemical looping uses metal oxide particles in high-pressure reactors to burn fossil fuels and biomass without the presence of oxygen in the air. Metal oxide provides the oxygen for the reaction. Chemical looping is capable of acting as a stopgap technology, in the opinion of the authors of the study, that can provide clean electricity until renewable energies such as solar and wind become more widely available and affordable. Renewables are the future, says Liang Si Fan, professor in chemical and biomolecular engineering, who's leading these efforts. We need a bridge that allows us to create clean energy until we get there, something affordable that we can use for the next 30 years or more, while wind and solar become the prevailing technologies. So this is somebody working on a fossil fuel burning clean burning technology that is saying the future lies beyond this and not too distant. 5 years ago, Fan and his research team demonstrated a technology called coal direct chemical looping, CDCL combustion, in which they were able to release energy from coal while capturing more than 99% of the resulting carbon dioxide, preventing it from going into the environment, therefore not contributing to global warming. The key advance of CDCL came in the form of iron oxide particles that supply the oxygen for chemical combustion in a moving bed reactor. After combustion, the particles take back the oxygen from air and the cycle begins again. The challenge was how to keep these particles from wearing out, says Andrew Tong, research assistant professor of chemical and biomolecular engineering at Ohio State. While 5 years ago, these particles for CDCL lasted through 100 cycles, which was more than 8 days of continuous operation, the engineers have since developed a new formulation that lasts for more than 3,000 cycles, 8 months of continuous use in laboratory tests. And it's now the similar formulation has also been tested at subpilot and pilot plants. This is Tong in quotey voice. The particle itself is a vessel, and it's carrying the oxygen back and forth in this process, and it eventually falls apart. Like a truck transporting goods on a highway, eventually it's going to undergo some wear and tear. And we're saying we devised a particle that can make the trip 3,000 times in the lab and still maintain its integrity. This is the longest lifetime ever reported for the oxygen carrier. He adds, the next step is to test the carrier in an integrated coal-fired chemical looping process.
How do they make the iron oxide particles?
I don't know. Probably by burning
fossil fuels? Yeah. That's what I was wondering.
Another advancement involves
iron oxide particles to make more iron oxide particles.
Another advancement involves the engineers' development of chemical looping for production of syngas, which in turn provides building blocks for a host of other useful products, including ammonia, plastics, or even carbon fibers. This is where this technology gets very sort of interesting. Provides a potential industrial use for carbon dioxide as a raw material for producing useful products. So right now, carbon dioxide is scrubbed from power plant exhaust, and then it gets buried in a hole somewhere so that it's not in the atmosphere.
What could go wrong?
Right. In this scenario, scrub carbon wouldn't need to be buried. It could actually be converted into plastics or ammonia or other
We
raw
don't need
material
more
stuff.
plastics. Get out of here with your plastics.
Well, if you're making them from what is essentially a recycled material, you don't need to be using raw oil from. Well, you can recycle plastic. We probably have enough. Taken together, Fan said these advancements bring Ohio State's chemical looping technology many steps closer to commercialization. He calls the most recent advances significant and exciting. It is his own research. And it has been a long time in coming. This is Fan's results here are from 40 years of research at Ohio State. Throughout some of that time, his work has been supported by the U.S. Department of Energy and Ohio Development Services Agency. This is my life's work, Fan said. And Fan, of course, is also the one who, at the beginning of this story, was basically saying this 40 years of work, this lifetime effort of his, is just to get that bridge to the next 30 years from now, when he believes the alternative energies will be taking over.
Very cool. One could say that Fan is a real fan of this research.
Huh.
Yeah, no, this is interesting. It's something I haven't heard a whole lot about, which is this meanwhile scenario. And we're just kind of waiting like, okay, come on, Solar. Where are you? Let's go. Let's go. Which I do feel like we could do. It's fairly ready, but it would take enormous government subsidies, which are not coming. So the stopgap really is the limiting factor right now, because for every day we're still using coal, oil, and natural gas, we're pumping more and more carbon dioxide into the atmosphere we don't need to be. So I think this as the end solution would concern me, but as a stopgap has me really excited.
Yeah, well, and then the 50% reduction in syngas production, this is the sort of thing that as we advance with technology, we get closer and closer to solving the problems that we wish we had solved a long time ago. Right. And yeah, we may be heading to a future without fossil fuels. But in the meantime, if there is an economically feasible way to reduce the carbon output that we're doing now, we create an incentive for them to do it now. Because we're in for a lot more warming regardless. The sooner we can start reducing, not just using a little less or being more efficient, but actually reducing the carbon footprint, the better.
Yeah. I am a little concerned that someone is going to see this and go, great, problem solved. We found it. We're good. Not look at it as like this stopgap. So the scientists see it that way because they're looking at this big picture. But I could see the powers that be saying, put it all in there. Let's just do this now. That's it. Forget about solar. Here's our deal. And
yeah, and in a way, I don't know. I don't think it's going to be that bleak, because I think the competition is already taken off in the direction of at least solar. I mean, wind is there too, but the part of the problem in all of this has been that coal and oil companies aren't in the energy business. As odd as that might sound, they're not about finding solutions to provide energy for people.
Right.
They're mining, distribution, refining companies. That's what they're good at. They're good at pulling stuff out of the ground, refining it into a product, and then sending it out. So they aren't really tied to or interested in the energy providing side of it as much, right? And there's very little in common between a mining operation, which is like an oil company, and a energy production solar powered plant. They have nothing in common, so in the technology or any of the rest of it. So So what you're going to find is people who realize that they can be in the energy business through solar. And there's a lot. I mean, I can't even. It used to be there was like just a handful of solar companies that you could go and talk to if you wanted solar panels on your roof or were interested in that sort of
mom
technology.
and pop around the corner or something. Yeah.
Yeah, and now it's kind of everywhere. Like there's a new company showing up every day, and I don't know if any of them are actually making their own products or these are just sales fronts for a smaller group of solar producers. But that technology is here, and it is showing up more and more all over the place. So,
and there are more and more areas where you can pick solar energy on your electric bill, which is really the key, because I feel like there's so many people renting out there. There's so many people who can't afford to install, but who would pay an extra couple cents per kilowatt hour to use solar power, and eventually it'll end up being the cheaper option.
Yeah.
So,
and actually, Tesla's Powerwall is in a way in the energy market because they've got this. So you take the giant Tesla battery, set it up in your garage, and even if you don't have a single solar panel, right? Electricity is cheaper in the hours when people aren't using it overnight, like 2 o'clock in the morning. So from like, maybe 1 a.m. to 4 a.m., it just charges up this battery. And then in the peak hours, when electricity is the most expensive, it provides it to the house, right? So there's all sorts of people who are jumping into the energy business in different aspects and different ways who are attacking this problem.
Right. Well, there's lots of ways to help with the individual consumer, but ultimately, you're not going to do much unless you can change the way industry gets their energy, which I think is what this story is all about. So that's pretty exciting. I have some other exciting news to share on the show. Are you ready? Yeah. So it's about bats. Our poor friends, the bats, they have been through so much hardship. They have just been pummeled by a lot of problems, but mainly white nose syndrome for the past several years, probably close to a decade at this point. But these guys, we just keep thinking we have a solution, and then it fizzles out, and then we think, oh, we found some bats that are resistant. How can we tap into this? And it kind of fizzles out. So this is really fascinating. This is a new study from the University of New Hampshire in conjunction with the U.S. Forest Service and U.S. Department of Agriculture. And they found that the fungus that causes white nose syndrome, which, remember, we only found out a couple of years ago that white nose was caused by a fungus at all. But we found out now that this fungus is highly sensitive to, guesses? No guesses, Justin? Do you have a guess? What is it sensitive to?
Sneezes. No, I don't have any.
Good guess. Peppermint? No. It's actually UV light.
Oh.
UV light. Yeah. So Pseudogymnoascus destructans, P. destructans, the fungus that causes white nose syndrome, can only infect bats during hibernation because it has a very strict temperature growth range. And so since it's kind of in this very specific niche of being in the hibernation times, they thought they would try all this kind of other stuff to see if there's a sensitivity. And they found that UV light does have an impact on the fungus. They're unable to repair DNA damage caused by UV light. And so this could actually be a way to treat bats for white nose syndrome. Just go in there with your UV flashlight. So as we know, bats play a really important role in habitats, and so a loss of entire populations of bats can be really damaging to those habitats. They're pollinators, they control pests. There's huge impacts from the loss of bats. And so being able to do something about this white nose syndrome could really be a huge boon to not just their population, but the population of lots of plant and animal species. So they found that a low dose exposure of UVC light resulted in about 15% survival of the fungus. It's pretty low. But a moderate dose of UVC light resulted in less than 1% survival of the fungus. This is only a few seconds of exposure from a handheld UVC light source, like a flashlight.
Wow.
So the next step now is follow-up research to see if UV light can be used as a treatment in the wild. They're going to measure the survival of little brown bats during hibernation after being treated with UV light compared to control groups. The important part of this study, which I'm really happy to hear, is that they are also going to measure quote-unquote non-target effects, including fungal and bacterial communities on the bats that are beneficial. So they want to see the microbiome in the bats, make sure that they're not getting murdered by the UV light as well, because that would be no good.
Yeah.
So this is a huge ray of light, you could say, in the story of white nose syndrome and bats.
So yeah, UV is a pretty typical lab disinfectant.
Yeah, well, think about like the toothbrush disinfector. That's just a UV light.
Mm-hmm.
Yeah, there you go. So who knew UV lights might save bats? Fingers crossed. Do you have any more stories, Justin?
I just pulled one. I'm gonna just found it. This is actually, I've been asked this question more times than I can remember. Where is there a cure for tinnitus?
Nope. Your hairs, once they're dead, right? Is that the deal?
Yeah.
No, tinnitus is the drum.
No, tinnitus is that ringing. It's the ringing in the ears.
But I thought that was an eardrum issue, or is that the hair issue? Inner ear hair.
I don't know. One of the things that I always thought was interesting about what you just brought up, though, about the ear hair thingy, and yeah, there's plenty of drummers I've met who can't hear at all. Right? They just didn't wear the protective ear coverings or earplugs or whatever. Drums are loud. Drums will ruin your ear. But there's been these rock stars who go up and perform, stadiums with the big speakers and the real loud concerts over and over throughout their life, still have really good hearing, are still right there, and haven't ruined their hearing despite having gone to more concerts than anybody else. This has nothing to do with that. Millions of Americans hear ringing in their ears, says the study, a condition called tinnitus. This new study shows an experimental device could help quiet the phantom sounds by targeting unruly nerve activity in the brain.
So this isn't fixing. I just looked it up too. Tinnitus can be caused by both. It can be caused by degeneration of inner ear hairs, or it can be caused by a ruptured or damaged eardrum. Either way, you can get tinnitus, which is just the word for the ringing in the ear. So it sounds like they're not going to fix those structures, but they could fix the ringing.
Right. So now I've never put this together. They help quiet phantom sounds. It could be like a phantom limb, where the brain is looking for input from a broken structure and getting a bad signal back, which the brain is interpreting as sound. In a new paper in Science Transitional Medicine, the team from the University of Michigan reports the results of the first animal test and clinical trial of the approach, including data from 20 human tinnitus patients. Not a huge sample. There's millions of people with tinnitus. They should have been able to find more people. But based on years of scientific research into the root causes of the condition, the device uses precisely timed sounds and weak electrical pulses that activate touch-sensitive nerves, both aimed at steering damaged nerve cells back to normal activity. Human participants reported that after 4 weeks of daily use of the device, the loudness of phantom sounds decreased. The tinnitus related quality of life improved. A sham treatment, placebo, if you will, using just sounds, did not produce such effects. Results from tests in guinea pigs The double-blind human study funded by the Coulter Foundation validate years of preclinical research funded by the National Institutes of Health, including previous tests on guinea pigs.
How do you know if a guinea pig has tinnitus?
You ask it. But how is that hard?
What?
They say the brain, and specifically the region of the brain stem called the dorsal cochlear nucleus, is the root of tinnitus. So Susan Shore, PhD, the Medical School professor who leads the research team. When the main neurons in this region, called the fusiform cells, become hyperactive and synchronized with one another, the phantom cell is transmitted into other centers where perception occurs. If we can stop these signals, we can stop tinnitus. She continues. That is what our approach attempts to do, and we're encouraged by these initial parallel results in animal and humans.
Very cool.
Yeah, the device approach called targeted bimodal auditory somatosensory stimulation involves two senses. The device plays a sound into the ears, alternating it with precisely timed mild electrical pulses delivered to the cheek or neck. This sets off a process called stimulus timing dependent plasticity, or STDP, which was first explored in animals and led to long-term changes in the rate at which nerves fire. Approach aims to reset the activity of fusiform cells, which normally help our brains receive and process both sounds and sensations, such as touch or vibrations. So this is they are attacking it at the nerve sites, but really they're making the adjustments in the brain. It sounds like they're retraining the brain to interpret its input.
Yeah, I mean, any way we can restore normal hearing, I'm on board with. I can't imagine what. I mean, I'll probably learn what tinnitus is all about because I do listen to a lot of very loud music. So,
but that might not do it. So, but it's 15% of Americans have some level of it, but the worst symptoms occur in about 10% of sufferers. So that's 10% of the 15%.
Yeah.
So really, it's only 1.5%.
But maybe this will all be a thing of the past, because once you get tinnitus, you can just go to the doctor.
And get this device
There you go. Trick your brain into thinking there's no ringing. You're all set.
Mm-hmm.
There we go. There's like a real life Baby Driver story. Okay. Did you see that, Justin? Baby Driver? No.
No. This is I'm just reading onto the story for the first time, so I'm getting very interested in it. Hang on. They recruited for this study, though, a particular kind of tinnitus sufferer. There are those who suffer from this who can temporarily alter their symptoms if they clench their jaws, stick out their tongues, or turn or flex their necks. These maneuvers, Shore says, appear to be self-discovered ways of changing the activity of fusiform cells, providing an external somatosensory signal to modulate their tinnitus. So in a way, people were already sort of self-medicating with a form of this therapy.
Wow. Neat.
And after patients had the device calibrated to their own symptoms, they learned to apply it earphones, electrodes for 30-minute sessions each day. So they're not running around with this. This isn't a device you have to wear constantly to counter the effects. This is 30-minute sessions a day.
Wow.
Interesting.
Yeah, the hit movie Baby Driver, he has tinnitus, and so he plays loud music to drown it out. It's part of the main premise, but never mind. This is This Week in Science, not This Week in Movies. I have one more science story to share before we close out the show, also related to new kinds of medicine. And this is about submarine bacteria.
Oh, I saw this story. This sounded cool.
Yeah. Researchers from Caltech are making strides figuring out how to turn bacteria into little submarines with sonar detectors that can tell us what's going on in the body. They have, for the first time, created bacterial cells with the ability to reflect sound waves from inside your body, reminiscent of how submarines reflect sonar to reveal locations. They are hoping someday to be able to inject therapeutic bacteria into a patient's body and then use ultrasound machines to hit the engineered bacteria with sound waves to generate images that reveal locations of the microbes. Then they would use those pictures to let doctors know if treatments made it to the right place and if they were working properly. This is great. Schlinger Schaller, a Heritage Medical Research Institute investigator, says, "We want to be able to ask the bacteria, 'Where are you? How are you doing?' The first step is to learn to visualize and locate the cells, and the next step is to communicate with them." Shapiro says that he had a eureka moment about 6 years ago when he learned about gas-filled protein structures in water-dwelling bacteria that help regulate organisms' buoyancy. So he thought that he could take these structures called gas vesicles and use them to bounce back sound waves in ways that would make them distinguishable from other cells. So then he demonstrated that gas vesicles can be imaged with ultrasound in guts and other tissues of mice. Then they transferred the genes for making gas vesicles from the water-dwelling bacteria into E. coli, which is commonly used in microbial therapeutics, like probiotics. So we wanted to teach the E. coli bacteria to make the gas vesicles themselves, said Shapiro. "I've been wanting to do this ever since we realized the potential of gas vesicles, but we hit some roadblocks along the way. When we finally got the system to work, we were ecstatic."
Everybody's happy about their research today. I love it.
I know. Nobody's saying, this research didn't really turn out how I wanted.
Well, some people did say apparently we didn't do their stories.
Yeah, so these little bacteria submarines could go into your body and go boom, 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 and tell doctors what's going on inside. There you go. All right. I think we may have done it. Would you agree?
Yes. Now this was for those of you who are listening. We are missing our Dr. Kiki for this show. Yes. We had planned for our predictions show where we go over last year's predictions for 2017. See how we did. I looked over mine. I think I'd been drinking before I wrote it.
Mine were pretty far-fetched overall.
Yeah.
I went fantastical. The year before that, I was very practical in 2016. In 2017, I threw caution to the wind. I was pretty fantastical with my
guesses. I think Kiki's actually all came true.
Probably. She's pretty smart.
Yeah, she kind of actually took the task seriously.
Yeah, she's got a pretty impressive head on her shoulders.
Yes. So my prediction is next week we will be doing a prediction show.
Yes.
And I will try to bring predictions that will happen.
I predict you'll get about 50-50 in 2018.
Oh, that's pretty good. That's not bad.
All right. So before we close out the show, I'm going to remind you once again that TWIS calendars are available on our website. That's at www.twis.org. Click on the calendar in the upper right-hand corner of the page and go ahead and order some calendars for 2018. Color your way through the year. Also, please join us in San Francisco if you're around, or if you just fancy a trip to San Francisco where you're not under 5 feet of snow. Like in New England and other places on the East Coast. And you can join us out here for SF Sketchfest Nightlife. That's on Thursday, January 18th at the California Academy of Sciences. Now is the time in the show where I want to thank our Patreon sponsors. I guarantee this is something I will not be able to do with quite the proclivity that Kiki has. But here we go. I'm cheating and I'm using the video from last week because I don't have this video. See what I'm doing? Yeah. Life hacks. All right, here we go. All right, thank you. Honey Moss, Aaron Luthen, Adam Mishkan, Alec Duty, Alex Wilson, Andy,
Adam Mishkan,
Arlene Moss, Artyom Ben Rothig, Bill Kersey, Bob Calder, Braxton Howard, Brendan Minish, Brian Hendrick, Brian Condren, Bruce Cordell. Oh my goodness, I'm
Byron
so
Lee.
bad at this.
Wait, go back. You missed one.
Oh my gosh.
No. Now I'm wearing a different shirt. Wait.
No.
Right.
Okay, here we go.
Bruce Cordell, Byron Lee, Charlene Henry.
I'm starting over. Here we go. Okay. Thank you to your Patreon sponsors. Go ahead, Justin.
Honey Moss, Aaron Luthen, Adam Mishkan, Alec Doty, Alex Wilson, Andy Groh, Arlene Moss, Artyom, Ben Rothig, Bill Kersey, Bob Calder, Braxton Howard, Brendan Minish, Brian Hedrick, Brian Condren, Brian Hohen, Bruce Cordell, Byron Lee, Charlene Henry, Christopher Fredire. Oh, thank you for pausing it. Christopher Rappin, Columbo Ahmed, Craig Porter, Dale Bryant, Dana Pearson, Daniel Garcia, Darwin Hannon, Daryl, Dave Neighbor, Dave Wilkinson, David Friedel, David Simmerly, David Wiley, Donald Trump the Dubious, Doug Campbell.
See, it's not so easy, is it?
It's hard.
Edward Dyer, Emmer Grenier, Eric Knapp, Eric Wolf, Felix Alvarez, Flying Out, Gary S., Gerald Serrels, G. Burton Lattimore, Gerald Onyago, Greg Gutham, Greg Riley, Harun Sarang, Hexator, Howard Tan, Illumalama, Jacqueline Boyster, Jake Jones, James Dobson, James Randall, Jason Dozier, Jason Olds, Jason Roberts, Jason Schneiderman, Gene Tellier, Jim Drapeau, Joe Wheeler, John Atwood, John Crocker, John Gridley, John Ratoswamy, Keith Corsell, Ken Hayes, Kevin Parachan, Kevin Railsback, Ksenia Volkova, Kurt Larson, Larry Garcia, Layla Louis Smith, Mark Mazzaros, Marjorie, Mark Marshall Clark, Matt Sutter, Matthew Litwin, Mitch Neves, Moore Cowbell, Mountain Sloth, Nathan Greco, Orly Radio, Patrick Cohn, Paul Stanton, Paul Disney, Phil Nadeau, Philip Shane, Randy Mazuka, Richard Hendricks, Richard Onimus, Richard Porter, Rick Ramos, Robert Aston, Rodney, Rudy Garcia, Solgood Sam, Shuwata, Sir Frankadelic, Stefan Insom, Steve DeBell, Steve Lesseman, Steve Mushinsky, the Harden family, Todd Northcutt, Tony Steele, Tyler Harrison, Tyrone Fong, Trainer 84, and
Ulysses Atkins. We did it! I can't believe we got through that list of wonderful people.
Yikes, that is not easy.
How does she do it? She just rattles them off.
Gosh, I can't. Wow. I wonder if she practices that. Well, thank you to everyone who support us on Patreon. If you're interested in supporting us, you can find us at patreon.com/thisweekinscience. Remember that you can also help us out simply by telling your friends about TWIS. On next week's show, we will be broadcasting live online at 8 p.m. on twis.org/live. We will be back with Kiki, our captain. Oh, Captain, my captain will be back. Thank goodness. We will be doing our prediction show. It will be fantastic. Yeah. But don't worry if you can't make it, because you'll still be able to watch us later. You can find past episodes at youtube.com/thisweekinscience or twis.org.
Thank you, everyone, for enjoying the show. TWIS is, of course, available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have the mobile type devices, we're on your phones too. Look up TWIS #4 Droid app on the Android Marketplace, or simply This Week in Science in anything Apple Marketplace-y.
For more information on anything you've heard here today, show notes will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts and other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair Baz at twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIScience, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 I've got one disclaimer, and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And this week in science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This week in science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 This week in 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 science.
We did it! Justin's not back yet. But we made it. Whew. My goodness. I apologize for the bad music audio. I did not have time to set up my soundboard before the show today. Actually, I have some notice and I have to clear off a whole section of my desk, install the soundboard, change a bunch of my settings on my computer. It takes over an hour. So that's the only way I can play sound from my computer to the video. So I had to use my phone today. But oh well, it'll get patched in later, right? Fix it in post. Thanks, WizMike. I'm no replacement for Kiki, but I tried. My goodness, I tried. But we did it. We brought the science. Hopefully Kiki's feeling a little better.
My last understanding was that she was not
feeling better. Yeah.
I don't mean it. Actually, it sounds like the worst of it's over, but it sounded like it was an exhausting day of being sick earlier.
Yeah. The stomach flu makes you wish for death. I can attest to that. And you can't do you can barely stand. You can't stand, really.
Yeah.
Last time I had the stomach flu, I had to have someone come pick me up from my house because I was home alone. Pick me up, help me to the car in my pajamas, drive me to their house so that they could make sure that I didn't die. Because I couldn't even like crawl to the kitchen for water. Like that wasn't even an option.
Yeah. I got something like that a couple years ago. And I remember I told everybody to stay away.
Yeah.
But I was like, oh, maybe this is it. This is how I die.
Yep,
Alone, curled up, just feet from the porcelain bus that I've been driving all morning to no avail. Haven't gone anywhere. But that's fun too. That's, it's a good day. It's a day without other responsibilities.
It's fun. What the? Who are you?
It's like a vacation.
No.
From...
No.
Yeah, it's not all bad. I mean, it becomes your job at that moment just to survive, just to be sick. Just dry heave a couple more times.
Just pretend you're sick and don't go to work.
No, then you've still got to do things because you still have an active mind body thing going on. When you're sick, you have no choice. It's like a forced vacation. It's like you're taking this day out of reality.
I guess. Can we talk about one thing since it's the after show? I didn't want to bring it to the real show because it's not science, so I don't even want to give it the airtime for the actual show. But I want to talk about raw water. Have you heard about this, Justin?
No.
Yes.
I haven't.
This is a new thing. It's called raw water. It is going for around $37 for 2 liters. It is spring water that is completely untreated, that they're saying has all these sorts of beneficial health effects.
I love it. Without data.
Claims
without data.
And it's on their website. It says everywhere, like, this product has not been evaluated by the FDA. Check with your healthcare provider before changing your water source and all this kind of stuff. But then they also say, like, oh, there was a woman who was having trouble producing milk and couldn't breastfeed her child. And then she drank raw water and now she can breastfeed her child. And also saying that chloramine and fluoride in the water, mind control.
Well,
one of these things.
That's true.
Fluoride? Mind control? That's true? Okay. I'm not really gonna respond to that.
No, it's all true. That's why I don't drink water.
Right. Yeah. But so yeah, of course, healthcare providers around the world are saying, like, don't drink raw water. You could get giardia. You could get dysentery. You could get all this kind of stuff. And also, this these people who are proponents of raw water are also telling you to go out, like, essentially trespass and go find a natural spring in the dead of night and harvest your own raw water.
So, yeah.
Yikes.
So I've
cholera, Schnogo, exactly. Cholera.
So I was hiking up to a glacier in Greenland. And it was really stupid because everybody else had turned back, but I was like, it's just over the next ridge. I'm gonna go over there, touch this glacier, and then come back. It was way further away than I thought it was. It was a much bigger glacier, but I got there. And it had, at one point, it was a little freaky because I could hear running water, but I couldn't tell where it was coming from. And it was coming from beneath my feet somewhere. Like a little way, like I realized, like, I'm standing on a creek. can't see it. And so then I like followed the sound for a while, and I found this area where this water was coming out. And I've been hiking for like half a day. So I was like drinking this water, like, fresh glacier water. And immediately I'm like, oh, that was probably really stupid.
Yeah.
like just because it's a glacier, just because I'm in Greenland, just because it just seems like this is like idealized source of what doesn't mean anything. Who knows what kind of extremophile or whatever I didn't even maybe extremophile. Like, who knows what I just ingested? And it's fine. I didn't have any ill effects from it, but I kind of get the idea. Although I had been hiking for half a day and was very thirsty and would have drunken from a muckish puddle at that point.
Yeah. So anyway, it's that's the thing going around right now. Hey, maybe filter your water. Just a thought. Okay, moving on.
Oh, yeah. Yeah, strengths. And then immediately I started producing milk. It was amazing.
Yeah, there you go. There you go. You did it. You did it.
Yeah. What's the promo? What's the promo for that? Our water will make you lactate. Wait. I don't want to lactate. Got no use for that.
Yeah. So anyway, that was all over the interwebs. I wanted to mention it, but
that's funny.
Yeah, raw water.
There's a story I didn't bring, but I thought it was kind of interesting, but now I can't find it.
Yeah.
Oh well.
Well, you can bring it next week.
No, it's not. It's an after.
It's an after show story. Thing.
What the heck happened to it? It was paraphrase it. That won't do it justice.
I have lots of weird things on my desk right now.
Oh, they did a study where they compared 4-year-old humans to other 4-year-old humans.
Say it again.
Well, you're always making fun of how they like compare animal intelligence to toddlers. This is when they compared 4-year-old children to other 4-year-old children.
Nice.
But one of the groups was Native American children, and they had, I guess, a much better sense of ecology than the non-Native American rural raised children. Where was this story that I saw? Now it's totally lost.
Out of water.
It's too bad. It was really. Oh, here it is. No, that's not it. Oh well.
Better find the nearest spring. I'll be right back. I had to ration my water tonight because I knew I couldn't use the restroom during the break. I usually drink like a whole one of these during the show, but I only give myself that much. Yeah.
Huh.
Yeah.
Oh well.
So I did all of my research on last year's predictions, but by the time I heard from Kiki that we were likely to be doing something else, I hadn't done my predictions for this year yet. So
oh yeah, I was like still doing a disclaimer.
Yeah.
And
Yep,
I did not. I guess that email went out earlier in the day. I didn't get it.
Sure did. You were on it.
Just note to future anybody trying to ever get a hold of me with any form of urgency. Text
email? What's with your TWIS email?
My email doesn't go boop boop. You have an email. It doesn't do that because it would be just ridiculous. Be doing that all.
Why?
Because the email is like. It's like I haven't checked my email or my actual mailbox in a month. Like there's never I don't need it for anything.
You need it for TWIS. What are you talking about?
Nah, you can just text me. That's how you get a hold of Justin.
Well, but sick Kiki emailed you. Hence my point.
Yeah, but when's the last time that there was an urgent pre-show email that was here's what's going on, big change in the show, We're like, anyway. I can't believe I lost that story. That was so interesting. Basically, it was a story about. Oh, yeah. Oh.
Good one, Fada. Good night, Fada. He said, let us all be simply thrilled and fascinated by our own research.
Good idea.
Not undersell it. You cannot overstate the implications of my study, sir. I love that. The importance of this finding cannot be overstated.
I think you just did.
How's your New Year, Justin? Did you celebrate East Coast New Year's?
We didn't even make it. So
you didn't make it to East Coast New Year's?
No, because a very good friend of ours is a classmate of my youngest and was born on the 31st.
Mm-hmm.
So we had a birthday party, which included lots and lots of running around and high energy playing. So kids are wiped out. We had to push East Coast New Year's to like 8 o'clock Pacific time, which is an hour early. So we did it really early.
Mm-hmm.
And that was kind of it.
Good. I did not make it as I probably went to bed the earliest in many years that I've gone to bed. But it was still pretty late. I went to bed around a little before 2. I left the place I was at 1:15. It was it's pretty quick. It was kind of like, okay, New Year's happened. Okay, let me help you clean up. I'm out. But it was fun.
Where did I find this story? I found this story about this drug that we've spent billions of dollars on, and by all accounts, it does nothing. Oh well.
Next time in the after show.
Yeah, next after show.
Cool. Okay, I think maybe I'm tuckered. I was really juggling.
Yep, you did good.
I'm sorry I started late, everyone. I really wanted to start on time, but it didn't happen. It was so Google, you know I love you. But not only does Google Hangouts change their interface constantly, but always between the last time I started the Hangout and the next time I have to host the show, they change a whole bunch of the interface between how Google talks to YouTube and how YouTube, like the menus and the buttons and it all changes. It changes so often. Why do they need to change it so many gosh darn times? You can improve functionality. You don't have to change visually how it works. Just saying. So it took me 25 minutes to figure out how to broadcast. And by then I hadn't done most of the pre-show stuff I normally have to do. So then I had to do all of that. So.
Well, the chat room was sticking with us. They were here on time.
Yeah.
They waited patiently for the show to begin.
Yes, they were great. And people watching us later on YouTube won't know we started late until right now. Oops. And people listening to the podcast will have no idea.
None whatsoever.
So. You're right, Ed. I should have had Karen do the Patreon reading. Where is she? Slacking. Gosh. Karen. Go drink more raw water, Karen. Ugh, gosh.
Oh, interesting. Ed found a story that that Americans are using a lot less water. Cut daily use by 6 gallons. A lot of the efficiency coming from California and Texas, which are experiencing droughts. Yeah. I'm kind of curious about this, though, because I'm wondering if that's individuals. Because in California is such an ag state. January 2014, Jerry Brown declared a state of emergency because of the record drought, asking Californians to reduce their water use by 20%. 2015, he increased it to 25%. There were stricter water use regulations in state and local government. Toilet flush standard is 1.6 gallons per flush nationwide. In California, it can't be more than 1.28. I'm totally buying a toilet out of state next time I need one. Part of the thing that this is like local state type politics and stuff, but one of the things that continues to annoy me about this debate about freshwater usage is agriculture is owned by more and more by fewer and fewer companies, and they've increased acreage of high water impact things like almonds, which I love. I would have almonds.
Almonds are not the solution. They're a scapegoat.
No, it's part of the problem. There's been a 25% increase in the amount of acreage used by almond farms in the last 10 years, and we're trying to conserve water because of droughts. It's something like 10% to 11% of water, freshwater usage by humans in California is by individuals, citizens and such. Showering, washing your car, watering the lawn, what have you. Vast majority of it is used by industry. So now asking individuals to conserve 20% is going to affect that overall number by like 2% of the amount of water usage. I don't know. I don't know if that's... It sounds like you're doing something and everybody's in it together and contributing and solutioning something, but it's a bigger problem. You got to look at where the bulk of that use is and how that can be addressed. And it really wasn't during the drought.
Meat's the problem.
No, you're not the problem, Blair.
Meat
I didn't mean to...
is the problem. Meat and dairy. Yes. Yes.
Part of it.
Have you ever seen a water use chart? I feel like you definitely have.
Yeah, I mean but I need hamburgers. That's the thing. It's like
if you look at per calorie of food created, it's like 10 times as much water as almonds to make meat.
Yeah, but that's if you're counting everything. And I mean that, I didn't mean that as offhandedly as it sounded. There's a lot of cattle that's raised in California, at least, is done so in wide open pasture type environments that they're not relying on. They're not watering.
Think about
the landscape.
The process from the birth of the cow to when you're eating it.
But they're not.
A huge amount of water that is not just them eating grass. There's a huge amount of water that goes into eating meat. This is the thing. This is the water use chart. Is always meat is up here compared to all the other stuff. Meat uses the most water of all foods.
But I feel like they're attributing that partly to the feed of the cows.
Only partially. They're looking at the whole agricultural industry. They're looking in California at all of the different sources of meat. They're not painting with a broad brush here.
I always feel like they are. I always feel like that when I see the, I mean, I'm sure if you are growing crop that you then are turning around and feeding to cattle, and that is how those cattle are eating, I'm sure that's a huge impact because cattle are big, they eat a lot. But a lot of cattle ground is not being human manufacturer fed. So
it doesn't matter. That doesn't matter. It's still
wonder.
No, it still takes into the equation about what's going on.
Usage chart. Oh, this is showing an individual. I don't want the individual. I want the big picture.
No, it's
right.
per the thing that I care about is per calorie or kilocalorie of food created. That's what should matter. Is how much water it takes to make a kilocalorie of meat versus how much water it takes to make a kilocalorie of almonds versus how much water it takes to make a kilocalorie of strawberries. That's the thing that accurately is a measure of what food item takes the most water.
Okay. So I found a different chart that has nothing to do with the big picture. It's the household picture.
Yeah, well, that's...
What do you think the two biggest usages of typical household water are?
Well, it depends on the house.
Just give it the top two, just based on a chart.
Toilets.
That is number one.
Yeah.
Number two?
Showers.
Showers came in a distant third. Clothes washer came in second. Toilet was 26.7 according to this chart that's unsourced from 1999. That's also before the high efficiency washers. I think if you got a front loader, that clothes washer number probably goes way down.
Oh, look at this right here. Here we go. This is exactly the juice I've been talking about. Okay, there we go. So this doesn't even get into almonds. But beef, a kilocalorie of meat of beef is 2.5 gallons of water.
Right. But
Yes.
this is my question on that.
Yeah.
Excuse me. Is that water that we had to assign to beef? Or
no,
it's
the process of getting beef from a baby to your plate. So water is used in processing the meat. Water is used in cooling the meat. Also, water is used to let the beef drink. Even if they're grazing, they still have places that they can go where there are water troughs where they drink. They still irrigate the lawn because otherwise the lawn would die. There's still huge amounts of water going to grass-fed beef.
Yeah, I just...
You don't want to believe it because you like your hamburgers.
No,
I get it.
No. I mean, I'm looking at one thing that says 816,000 gallons used during the life of the animal for cattle.
Sure.
You're eating grass that was grown because it rained.
No. You think the grass that cows eat is is watered by rain. You honestly think that?
And a lot of the big cattle.
Not in
northern
California. No, we don't get
No.
enough rain. We don't get enough rain in California to grow grass.
Yeah.
That is
The
not
big
a
cattle
thing.
ranches out near in Sonoma.
They have
It's
irrigation.
natural spring water. It's not
Nope.
irrigation.
No, they irrigate for sure.
Natural spring.
They are using water to grow that grass. Grass doesn't grow in a normal year-round pattern without help in California.
Maybe you're right.
But maybe. But look at
These
this.
numbers are all over the place.
Water footprint. This is per liter, though. This is why it's higher. So per liter per kilocalorie. Beef 10.5. Pork 5. Almonds 2.8. Milk 2.1. Brussels sprouts 0.6. Bread 0.6. Soybeans 0.48. Potatoes 0.37. There you go.
So wait. So we should be eating pasta.
Yep.
But wait, then you gotta boil water with the pasta. Is that counted in? Like, how do they do this? Oats?
That's
Are you supposed to eat them raw?
okay. Hold on. This is liters per kilocalorie. How many kilocalories, how many calories, as we call them, do you get out of a bowl of pasta, do you think?
I have no idea.
About
2?
400.
Okay.
And then you're probably making 2 or 3 servings of that. Let's say we'll just round it to 1,000 calories we're getting out of this batch of pasta that we used a quart of water. So not even, so a quart is what? It's roughly, it's a quarter of a gallon, so it's like half a liter. So that is half a liter for 1,000 kilocalories. So if you want to add that in, that would be another 0.005. It wouldn't even register on this graph. You dig?
Wait, I used per, what did you call it?
So if you get 1,000, technically they're kilocalories. That's what we're measuring on this. When you say that something is 1,000 calories, you actually mean it's 1,000 kilocalories. So we're getting 1,000 kilocalories from this pasta. We're using, let's say, a half a liter to boil it in. That means per kilocalorie, it's 0.0005. Is that right? 0.5 divided by 1,000. 0.0005. So nowhere near even registering on this graph. You're adding in per calorie to boil it in. So the point of this is, if you're eating a steak, how many calories is a steak? I wouldn't even know. How many calories do you think it is? 600?
No, I've never counted a calorie in my life. I have no idea.
Okay, so if a steak is 600 calories, then
you're 5.
then your water cost of that steak is 6,000 liters of water. That's why meat is an environmental disaster.
The way you say it makes me think it's true.
It's because A, I'm convincing, and B, it is true.
I don't know if it's true, but you are convincing me.
It's definitely true. That'd be quite the weird conspiracy theory.
Oh, wait. Is this the... Oh, this is a different one. Yeah, there's so many different numbers associated with these things, though. Chart after chart, and none of them like beef. But everything else is falling into different... Oh, wait, that's a whole different thing.
Well, it might be different y-axes or x-axes that they're measuring on. Like
Gallons per kilocalorie.
Okay, there you go.
2.5.
Yeah, that's what I was shown before. So this is per liter, so it's a little bit different.
Chicken and dried peas are the same. They're all at 0.45, 0.48, 0.45 for pork, 0.26 for egg. You can't count eggs and chicken at the same time.
Well, you're not supposed to count your chickens before they hatch. You know that.
Carbon footprint, beef is way up there. So is cheese and salmon. Why is salmon carbon footprint so high?
Because of the fossil fuels used to make the pharmaceuticals that they feed the salmon in farms. That's why you're not supposed to have farmed salmon, is because they pump them full of drugs. And so it's not good for you to eat, but also it runs off into the environment and it takes a bunch of fossil fuels to make prescriptions that they feed the salmon.
You know what's showing up as pretty low impact every on all of these though? What? Bread. Bread.
That's why people have been eating bread for, like hundreds of thousands of years.
We need to go to a all bread diet.
I would do that, but I would soon have to buy all new clothes. I tell you, the bread goes straight to my hips. It does. But it's so delicious. Okay. On that note, I'm gonna rest my weary bones, I think. Is that cool with you, bruh?
Yep. Good night. Good night, minions. We'll see you next week. Next week will be the prediction show where we predict the future.
Okay. All right. I love you all.
Say goodnight, Blair.
Good night, Blair. Say goodnight, Justin.
Good night, Justin.
And let's say it to her from afar. Good night,
Good night,
Kiki.
Kiki.
Good night, everybody. See you next time.